Hey, quick video on these momentum bar charts. This is especially for the second hour folks whose hour got cut a little bit short, but might help you in first hour as well. When you diagram the forces acting on these things, box 1, which had a lower mass than box 2, actually had 3 times more force acting on it for the same amount of time. Now, both of these started at rest, had some impulse applied to them, and then end up, moving afterwards. So here's the big idea. Any object's change, and I shouldn't say any object, any system's change in momentum is equal to whatever impulse was exerted on the system. So in this case, box 1 system initially had no momentum. It was at rest. Box 2 system initially had no momentum. Now here's one thing that, it'll vary from person to person. The impulse on box 1 is 3 times as big because it's 3 times the force for the same amount of time. Now I chose to scale my graph this way. You did not have to scale it this way as long as you made the force on box 1 3 times as big for the same amount of time. So the way I have things scaled, the impulse on box 1 is 90 units. The area of this rectangle is 90 units. The impulse on box 2 is only 30 units. It's a third the force for the same amount of time. So if the impulse equals the change in momentum, I start with no momentum, plus the impulse has got to equal my final momentum. So here's the trick. Box 1 only has a mass of m. So if you look at this graph, m is on the horizontal axis here. When you go to make your rectangle to represent box 1, it can only be half as wide as the rectangle that you make to represent the momentum of box number 2. In box number 1, you've got to draw 90 units worth of area in there because its change in momentum was 90 units, if you're using my scaling anyways. Box 2, it's got to be twice as wide because it's twice the mass, so it would have to be a rectangle that's twice as wide, but it can only have 30 units of area. So you're going to have to draw these rectangles over here, one in each different color that you chose to represent the objects. You're going to have to draw them accordingly. Now when you get to these questions down here, this one asks you about work done. Work, force times the displacement times the cosine of theta. Now, these things were pushed the same way they were moving, so you really don't have to worry about the cosine theta part because theta is 0 degrees. So they're asking you to think which box had more work done on it, or how did they compare? Down here, they're not asking you to think about work, they're asking you to think about impulse. So impulse is a vector, and it's force times time. Different ideas. Now when you get onto this second part, same idea. This truck has some initial amount of momentum. I chose 15 units. You did not have to choose 15 units. Now, impulse equals change in momentum, just like before. This is a truck coming to rest. It's got an initial momentum, but there is no final momentum. So whatever this impulse is, it's got to be the appropriate amount to bring this momentum down to 0. So keep that in mind when you think about the sign of the force being exerted on the truck.